So this is a map of the Arctic Ocean, and here you can very clearly see that the Arctic Ocean is a very deep central part, which is surrounded by shallow continental areas. So these shallow shelf seas, they're extremely shallow in some parts here, and they make out more than 50% of the Arctic Ocean area actually. So the deep part of the Arctic Ocean, it's like a little deep basin where you have a specific circulation. The first part of Swerus, leg 1, they started in Tromsø, and they went across the Barents Sea, came out through the St. Anna Trough, continued to Laptev Sea. They did some very exciting research here. It was here that they found that you had a lot of methane bubbles coming up from the seabed, for example. They also found interesting results of methane indications on the slopes here. Örjan will tell you much more about these things. And they continued over the shallow area, and they worked in open water here, continued into a more heavier sea-infested area here, and ended up in Barrow here. And that is where we're going to rotate, here in Barrow, Alaska. So when we have rotated, leg 2 will start here, north of Wrangel Island. And here we have several goals. We are interested, for example, in the Pacific water inflow. That is important for the whole circulation system in the Arctic, because the Pacific water brings in a lot of fresher water into the Arctic. So it affects the whole circulation system. And we know that there are very thick sediment sections here. And the thick sediment sections are interesting for us because if we can get them, we can get an archive and study, for example, the sea ice history and the history of Pacific water inflow. So we will start by trying to locate the best places to go and take some long sediment course and take the course here. After that, we will go out to the slope here. We plan to go out to the slope, it's better to say, and trying to shoot seismic and to see if we can see signs of gas hydrates and take a lot of sediment cores, because the sediments cores we can study the properties of the sediments, which is very important for the gas hydrate modeling. For example, we want to know the porosity of the sediments, we want to know the general heat flow. We need to know that, so we need to take temperature measurements into the sediments and also measure the conductivity of the sediments. So these parameters are important for the modeling, because if we don't get these parameters, we can model and we need to guess with all these different properties, and it's not really worth anything. So we need to have the real data to tune the models with. And then we're going to continue out and do this transect, hopefully, to meet up what we started in leg 1. Continue, work more along the slopes here to look for the gas hydrates and also take oceanographic stations. We have one feature which is very important for the whole Arctic Ocean, not only for the gas hydrate stability, which is one key thing, but also for the sea ice history and many other parts of the whole system, and that is the Atlantic water inflow. We know that the Atlantic water is coming in through the Fram Strait. It moves along the slopes here. It also comes in over the Barents Sea here, out through the St. Anna Trough, and they join up like that. Circulates around the Arctic like this, along the slopes. Portion moves over the Lomonosov Ridge, comes in over here, and then eventually finds its way out to the Arctic Ocean. And then it has cooled down. It comes in as a couple of degree warm water, subsurface. And this warm water is very important, because if it hits the slopes, which it does, it will affect the gas hydrate stability. So if you increase this influx, you might destabilize the gas hydrates. The gas hydrates are stable here along the slope depending on pressure and temperature. So the Atlantic water story is very important for us, and we also want to know this back in time, which means that we are taking sediment cores and we're trying to get the proxy, some indications that we can calculate temperatures on. We normally do that on, or we're actually looking at new methods to look at foraminifera, calcium carbonate shells from foraminifera, and then we look at isotope compositions and trying to and magnesium calcium ratios and also other things to try to estimate sediments in the past, temperatures in the past. Once we have completed this very comprehensive program, which is a lot to do, then we're going to finally go over the Lomonosov Ridge here out. We have a transect we want to do out on the Lomonosov Ridge to capture many different properties along the ridge here, and then eventually go across the basin and back and end up in Tromsø, where we jump off the ship and we finish the leg 2 of the expedition. So that is the plan, and then we will see with weather and wind and ice, etc., what we can complete of this very comprehensive plan.